So the next is that due to air pollution, so what are the global effects, like, or global problem we have? Okay, so one of them is the ozone layer depletion. So we'll be discussing that what are the air pollutants are responsible for the depletion in ozone layer. Now we know that ozone is an important species in the atmosphere, acting as a protective layer. It filters out all the toxic radiation from the sunlight, and the maximum concentration of O3 that is in atmosphere is 10 ppm. Okay, so anything less than that or any depletion in O3 will be a problem for us because it won't be able to filter out all the toxic rays, particularly the UV rays that is coming from the sun. So, what is the basic reaction? So, how the ozone is formed in our atmosphere? So the photochemical reaction that is happening. So, where O2 in presence of light is being converted to nascent oxygen, then it again reacts with the oxygen molecule in presence of a precursor. So this precursor is your nitrogen and can be oxygen to give you this ozone. Okay. So this is the way how ozone is being formed in our atmosphere. Now the depletion or the removal of ozone, how it is happening in our atmosphere. So there are few radicals which are responsible for that. So we will see their reaction, how it's and which one of them is more harmful. Harmful in the sense means maybe one or two molecules should be responsible for the conversion of like thousands of O3 or depletion of O3. So nascent oxygen, hydroxyl radicals, nitric oxide, and chloride radicals. So these are the four pollutants you can say. So these are responsible for the removal of ozone. Now, how nascent oxygen is being involved? Simply, it reacts with ozone to give you oxygen. So, although it is responsible for the removal of O3, but at the same time, it is producing oxygen. So, which is another component that we need for life. But the O3 that we have in the atmosphere, so the prime job is to filter out. But if we remove or if we produce oxygen from that, then again that would be harmful in a sense that it will not be able to filter out all this toxic rays from the sunlight. The next is the hydroxyl radical. So hydroxyl radical reacts with O3 to gives you this O2 and peroxy radicals. Then this peroxy radicals in presence of nascent oxygen to give you back again the hydroxy radicals. So this is a chain reaction. So one of the hydroxyl radicals can consume many O3 molecules. So this is dangerous. So if the reactant is being created during the reaction, okay, so that is going to affect more in comparison to the other radicals. So in comparison to nascent oxygen, the hydroxyl radicals is more harmful in removal of ozone. The next is nitrogen oxide. So nitrogen oxide reacts with O3 to give you oxygen and nitrogen dioxide. Again, that reacts with nascent oxygen to give you back nitrogen oxide. So again, this is a chain reaction. So one nitrogen oxide can create or can be responsible for many O3 molecules consumption. Now the next is the freon or CFC, chlorofluorocarbon. Okay. So this chlorofluorocarbon in presence of sunlight that gives you this chlorofluorochloride radical, okay, and also chloride radical. Now this chloride radical reacts with O3 to give you this chloroxy radical. Then chloroxy radical in presence of oxygen gives you back again the chloride radical. So similar to nitrogen oxides and hydroxy radicals, this chloride radicals is also being generated during the reaction. So being a cyclic reaction, so it's again uh, like one molecule would be responsible further consumption of many O3 molecules. Now, in terms of if you compare the CFC or chlorofluorocarbon can destroy like 100,000 ozone molecules, one molecule only. So, so in terms of effectiveness, so these are like, harmful radicals, this particularly the chlorofluorocarbons. Now, we know that we have these pollutants in nature. Now, how also nature plays a role how to tackle all this, how to consume all these harmful radicals. So, how nature balance? So the chloride radicals that reacts with hydrocarbons to give you this methyl radical and HCl. This methyl radicals again gives you back this ethene gas. So in a way, nature is also plays its role to consume these harmful radicals. Similarly, the chloroxy radical that reacts with nitrogen dioxide that is already present in the atmosphere. So that gives you this chloronitrate or chlorine nitrate. So so the other components that is present in the atmosphere like methane and nitrogen dioxide, they also play a role to remove all these toxic radicals which are harmful or which are responsible for the removal of ozone from the atmosphere. Now, what is the history behind it? When we started to observe that there is depletion in ozone layer, then what is the reason for that? Now, these ozone depleting substances are present throughout the stratospheric ozone layer. But however, severe depletion of ozone has occurred in the Antarctic region. So, what is the reason for that? We know that any other parts of Earth, the air circulation is happening. Okay, but what happens in Antarctic region? So the air circulation creates a vortex. Okay, so due to the formation of vortex, so these radicals stays there because the vortex will rotate and keep the radicals or keep the pollutants or limit those pollutants there. They will not be diffused to the other parts of the earth. So this is one of the main region. And and this type of vortex almost stays for 5 months. Okay, so when your air is static, almost static for 5 6 months, then obviously the reactions that we discussed will happen very frequently, and they will start to remove this ozone. So that's why we observe this depletion of ozone layer in Arctic region or pole region, you can say that. Then again in very low winter, when the temperature is minus 90 degrees centigrade, in the Antarctic stratosphere, as polar stratospheric clouds, so they're commonly known as this PSC. The reaction that occurs on PSC is combined with the relative isolation of polar stratospheric air, so that is due to the vortex, allows certain reactions to occur leading to accumulation of chloride. So, so once you have accumulation of this chloride in atmosphere for a long time, then this the chloride radical will form also that will be responsible for the removal of O3. Now, in presence of sunlight, that is an Antarctic spring, okay, the chlorine undergoes photolysis, forming chlorine and chloro chloroxide radical, which removes. So presence of chloride, okay, creates two of these radicals. Okay, the chloroxy radicals as well as this chlorine radicals. So both are responsible for the removal of O3 from the atmosphere. Now, this is the basic reaction that is happening uh, in PSCs. So, what happens? You have chloronitrate or chloroxynitrate. So, in presence of moisture, that gives you this chloroxy chloride, chloroxy hydroxychloride plus HNO3. Then again, this hydroxychloride reacts with HCl to give you this chlorine gas. Similarly, this chloroxynitrate also can react with HCl to give you this chlorine, and ultimately, in presence of light, this chlorine gives you this chloride radical. And once we have chloride radical in the atmosphere for a long time, it will start to remove this ozone layer from the atmosphere. So this is the reason why we have ozone layer depletion in the Arctic region compared to the other parts of. Now, what are the effects, or how this ozone layer or depletion of ozone layer leads to different types of problems? Okay. So health problems, and also the 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 weather pattern also changes. Okay, so what happens? So once this UV exposure happens, okay, so that affects your lungs, which leads to bronchitis, and also obstruction of lungs leads to asthmatic problem. Now also 0.3% to 0.6% increase in risk of cataract. Okay, so if you're exposed to UV radiation, your eyes, okay, so so the percentage of cataract increases. Okay. So even only 1% decrease in ozone level. Okay. So imagine if the percentage goes more, then obviously the effect of, or the cataract percentage will also end. Because the cataract problem, it is, we say that this is a problem of old age, okay, but not really. Nowadays we may have this kind of problem of almost every age. So like in the young generation having this kind of cataract problem also. So it is no more limited to the older generation. So it can happen younger age. So maybe the reason can be also the exposure to radiation, UV radiation. Then also exposure to UV radiation can also result in suppression of immune response to skin. Yeah, obviously. So if your skin is exposed to UV radiation, so we may get different types of skin diseases. So out of it, also skin cancer is possible, and also you may have different types of allergic reactions in your skin. Now, also the reduce of photosynthesis and alter developmental and physiological processes, and ultimately resulting in reduction of crop production. So, this also affects the photosynthesis process, and once that happens, or in any alteration is happening, okay, so it starts to affect the crop production, or the agriculture production. So it has a direct and indirect effect of depletion of ozone layer. Again, affects it also affects weather pattern through interference with oxygen. So these are the effects we may get due to the depletion of ozone layer. It is happening. Okay, it is happening also other parts of Earth. We sometimes we may notice, sometimes we may not notice, because the particularly the weather pattern. So if you look, the weather pattern is changing a lot. Like even if I compare the last 20 years, so particularly in summer, okay, if you see, the summer is now become more hotter nowadays, and also in summer we have a like the almost every day we have rain in summer. We used to have also. But normally that rain happens around 4 o'clock or 5 o'clock. Okay, just other part or afternoon session. But if you notice, for a couple of 2 to 3 years, particularly in this region, this rain has moved to midnight or like early morning. So why these kind of things happen? So if you go deeply, okay, so directly or indirectly, so these are the response. Like maybe the changes in the atmosphere, okay, or or the release of toxic pollutants or air pollutants. So they are responsible directly or indirectly. because sometimes we may notice those things. Okay, sometimes we do not. We say that okay, we don't know whether we don't have control over weather. Okay, but to some extent, the, the 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 activities that we do in our daily life, in terms of industrial activities, in terms of transportation, so it is affecting our atmosphere. So, and which directly or indirectly affecting our the weather pattern, the crop health, also our health. So, so these are the things we may uh, get due to the depletion of ozone layer. The next one is the global warming. Okay. So normally we this is a big debate, and every year uh, all the developed and developing nations are debating about this, that how to control this, and and particularly the developed nations are pushing with they're with more hearts towards the developing nations to decrease their industrial activities, but the developing nations are the economy is depending upon the industrial activities. For example, the all this manufacturing activities nowadays move to Asian countries. So almost China, Malaysia, Indonesia, then also partly India, and also in North South America region it is Brazil. So all these developing nations, okay, so their economy nowadays depending upon the industrial activities. West is more or less now silent because nowadays the industrial activities is pretty much silent in West and also in America. But uh, most of the if you say the manufacturing house of is basically the Asian countries. So obviously, if you have activities, industrial activities, so you'll be releasing different types of toxic gases. So there is a debate about different types of organization, having debates over the years how to control these things. So uh, also India has started to act on it. So that the result is all this the policies we are having now 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 in transportation all the vehicles or the engines are moved from BS4 to BS6. Then BS6 or BS4 we are still friends.
BS6.
BS6. Yeah,
Yes.
BS6. Then also you see the EV activities now, the EV vehicles. Okay, so you see almost two wheelers. Almost every companies are now releasing two wheelers based on EV or batteries. Similarly, in also in auto sectors, we'll have now at the moment is more passenger vehicles or personal vehicles, four wheelers. But in future, we'll have also the trucks, buses, and in EV. So we are trying for not to release or reduce the activities, reduce the natural gases or use of consumption of natural gases. So uh, the only the time will tell that how far we are successful, because uh, at some point we have to use also the natural sources. But if we can reduce the use of natural sources like petroleum products, we may also decrease the release of different types of toxic gases to the atmosphere. Now, in terms of the global warming power index, okay, so CO2 is contributing almost 50%. So it is to some extent it is we can say that it is good or bad also. Uh, because if you see the other components, okay, so for example we have hydrocarbons, they are contributing almost 19%. CFCs, okay, chlorofluorocarbon, contributing almost 17%. O3 is also contributing 8%. Other component like moisture or water vapor, although it is very less, 2%. Then we have this nitrogen oxides, that is contributing 4%. So if you see in terms of global warming index, power index, so CO2 has the lesser effect. So if we see that, let's say CO2 is X or one molecule, okay. So in terms of effectiveness, hydrocarbon or methane is 25 times more. Similarly, the nitrogen oxide is 150 times. And if you see the CFC, it is 10,000 times more effective. So, like if you have 10,000 CO2 molecules and one CFC molecule, okay. So in terms of uh, global or GWP, global warming power index, so it would be equal. Okay. So it's better to have CO2 rather than CFC. So so that's why the catalytic converter we have. So there the the toxic gases like carbon monoxide is being converted to CO2. So because CO has more toxic or toxicity in comparison to CO2. Now, what type of effects we have due to the global warming? So we know that if there'll be increase in temperature, so what will happen? So the ice that we have in Arctic region as well as in in the northern part of Europe or northern part of US, so they will start to melt. Okay, so once they will start to melt, those water will be end up in sea and will be responsible for the increase in sea level. Okay, these type of effects or the global warming or increase of temperature, decrease of temperature, these are natural phenomena. Okay. Natural phenomena means because if you see the the weather or the weather pattern in Earth, so there is different ages. Like there are two or three ice ages. So at some point, Earth was very cold. So all over there was ice. Then the temperature of the Earth increases. Then we have open lands. Then all the ice melts and they end up in sea. So similarly, after that we have again ice age. So this is natural. But what happens? So, due to our activities, we are changing the natural process. So, instead of having those kind of effects in millions or billions here, we are reducing that gap. So, this is the alarming. Okay. So, if we reduce this or affect these natural processes, then obviously it will going to affect our future generation. So, so the increase of temperature, which supposed to, let's say the 1 degree or 2 degree, that is happening or that may happen. So what is the statistics is saying nowadays? So if we go in this way, okay, if we do not control our activities, industrial activities, or the release of toxic gases or greenhouse gas effects. So if we do not control these things, so the increase of earth or the temperature of earth will increase. So it may happen in like 500 years or 1000 years within that period. Although it seems a long time or long, but in comparison to million years or a billion years, it is almost nothing. Okay, even not even 0.1% or 0.1% or 0.01%. So so we are affecting those natural cycles. So maybe I'm talking about 500. Maybe it is not true. Maybe even 50 years or 100 years, we are going to see the effects which are supposed to happen in billion or billion years. So this is the main issue that we have. Now, due to this, what happens? The global warming disturbs the balance of ecosystem by changing the salinity of ocean water at estuaries. That is basically the the connection point of freshwater with the sea. So due to which what happens the fish and the other organisms, okay, so one they die because of the warming temperature, because once you have the temperature increases, again it's going to affect the dissolved oxygen. Okay? It's going to affect different salt balances. So that directly affects the ecosystem. Now, warming of surface layer also prevent the transport of nutrients from differ layer to the surface, okay, due to this vertical circulation. So all these natural processes that is happening at some temperature, if we increase that temperature, it's going to affect. Now again, the global warming is projected to cause an increase in intensity or frequency in extreme weather. Okay, so this is what I was talking about. So whatever the irregularities we see in the weather pattern nowadays, it is directly or indirectly by this effect. Again, if we have irregularities in the weather pattern, then it would be difficult to control the agriculture activities, particularly the countries like India. We mainly depend on monsoon. So monsoon normally we have in from June to end of August or beginning of September. But if that starts to happen like earlier or later, so all these agricultural activities will be affected because mostly the farmers here in India depends on the monsoon, and based on that they they go for the agriculture activities. So if that is irregular or due to this irregular pattern of weather, so obviously or indirectly that is going to affect our crop production. So these are the global issues. So it is not only it is happening in India, it is happening in other parts of the world. So 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 due to this air pollutions, we are having this kind of problems. So besides these problems, okay, so by the global problems due to the air pollution, we may have the local problems, different types of local problems also. So this is the picture of melting of ice cap at pool. So the red line was saying like 1979 is, yeah. So within that, like if I compare, it's not only this 30, 50 years. So within 50 years, if you see the ice caps has melted almost half, or maybe 30 to 40% is decreased. Okay, within this 50 years. So it's an alarming situation. Although one can say that the ice that is already over the sea level is not going to increase the volume. Okay? The ice that is in the land part. Okay, if that ice melts, okay, so that will end up in the sea, and that will be responsible for the increase in sea level. But if this picture is true, okay, according to our data, then obviously this is an alarming situation for us. Yeah. So the next is the controlling measures that we are going to adopt. We are doing it uh, uh, both at domestic level as well as an industrial level. Uh, so in this category, we'll be discussing different controlling measures for air pollutants. So we'll have this catalytic converter. So that would be for the transportation system. Then we have the cyclone collector, electrostatic precipitators, cropping techniques. So these are all we have been using in industrial level. So yeah, so but we'll be discussing these things in the next class. So the what are the technology we are using in terms of converting the toxic CO gases that is coming from transportation, and what are the different types of catalytic converters. So there are two stage, three stage catalytic converters. So we'll be discussing that in the next class. Okay. Students, can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So for today, after this, the quiz component, the two global phenomena. One is the oxygen, the decrease in uh, ozone layer. The second one, the global warming. Okay. So you have this material with you. So just go through that. Do you have any doubts? Do you want to discuss something about global phenomena? How far is your group? Bhadranil, are you there? Subhadranil?
Yes, sir. So sorry, sir. I couldn't join because there was no network in the morning. That's why I joined 30 minutes late, sir.
Okay, so you're being honest. 30 minutes late. So I already put you in absent.
Excuse me, sir.
So can you
Yes.
please give me present, sir, this time, sir?
Sir, I was also
Let's
late,
see.
sir.
Yes,
No.
sir, me too. Very
Yes, sir,
bad.
me too, sir.
Yeah, there are many students I know.
Sir,
Almost. Okay, we
9
have
baje,
a,
the
now,
class.
now but it's too early, yeah?
The class was from 9 a.m. Now that's why we are. That's I am not knowing that the class from 9 a.m. My friend
So
just
you are
called
not
me at
used to 9 o'clock.
what, sir?
You are not used to 9 o'clock?
Sir,
Waking up?
actually, I am sleeping at near 3 to 4 a.m. Sir. That's why I can't able to wake up at
Wow,
9.
very good. Why at 3 o'clock, 4 o'clock? Huh?
Sir, actually, I am doing some coding stuff and all, sir, or anything.
Or playing games? Huh?
No, sir. Sir,
No,
who
no.
was there? Who was there at 3 and 4 a.m., sir?
Yeah, yeah.
No one is there,
And,
sir.
okay, okay. Anyway, see that. Okay, I think I've already assigned. Is it Amish Singh that I asked you to take
Yes,
the?
sir.
Okay, okay. So please take the attendance and now. How
Yes,
many
sir.
of you are present? Okay, so I can see 85. So 85 means, okay, me and my presentation will take two. So 84 students at the moment. So please. Okay, anyway, I have already shown the marks to the students, so those who joined later. So you'll get it in your mail, okay? So individually, all the three marks. Or so we have already three quizzes. So including today's one. So I'll try to uh, I'll communicate those marks to your mail, but give me some time. I mean, at the moment, almost for 2 to 3 days. For
No
last
problem.
10 days, I was like busy in different things, so unfortunately could not communicate all this marks. Although I was promising to other sections that I will do it. I will do it. Unfortunately, I can't do it. Could not do it. Anyway, so anyway, partly I have already shown to you your marks. So, but anyway, well, so you'll get individually in your mail for your reference, so that will not have any discrepancies in future. Okay, but be ready with the groups. Samudranil, what is the status?
I think there are only 4 people left. Like 90 people are already in groups. So I'm sharing the Excel sheet in the official EVS group, so people
Okay,
can see whether they are in the sheet or
yes,
not.
thank you.
Okay.
So do that, and I would like to say that okay, maybe we should start. When is your midsem? Midsem is starting from 18th. Yeah,
Yes, sir.
Yes, sir.
18th of April. Then after that, we will get 1 month in between, and from June first week, yeah, June first week is your answer.
Yeah, sir. From first
Okay,
week only.
yeah, maybe we should start our presentation ideally from
Up.
12th of May or something. Okay, so you have still you have some time. Please work on it on your presentation as well as your write up. Okay.
Yes, sir.
Anyway, by I think I'll try to give you the date, exact date of each group for the presentation. So ideally, we'll start either from 5th or 12th. So after your medicine, and after that 1 week gap is there. So then after that we'll start. So yeah, after midsem you'll get 1 more week, and after that the next class is on 5th. I either will start on 5th or 12th. Okay, depending upon number of groups and other things. Okay.
Say something.
Yes.
Guys, I've already shared the Excel sheet in the EVS official group. People who are left to be the names are left, so you can contact me or Amish Singh to put your names in the list because it's not edible. Okay, thank you.
Good. So thank you, Vadranil. So I can see that. So